together sort of as our notes, and then you're going to practice some on your own. So negative exponents. The first thing we're going to start with is actually not negative exponents. It is something to the 0 power. What is something to the 0 power? It is 1. Except there is one number that if you raise it to the 0 power, it is not 1. 1 to the 0 power is still 0. 0 to the 0 power, this is what we call indeterminate. Indeterminate, meaning that it doesn't really tell you anything. I'm not going to give you ones where you have 0 to the 0 power, really. I just want to point out here that 0 to the 0 power is the one time that it does not, that this does not equal 1. Anything else to the 0 power is 1. How'd they come up with that? Why is it not 0? It seems like it should be 0, doesn't it? If you have 0 ones, it seems like that should be 0. But it's not. It's 1. So, let me show you why it has to be 1. Okay? This is important stuff right here. So make sure you're paying close attention. What if we had 2 to the 3rd power? What does that equal? It is 8. Right? 2 times 2 times 2 is 8. What is 2 to the 4th power? I'm sorry. I didn't mean to go to 4th. What is 2 to the 2nd power? I meant to pick one. It is 4. 2 to the 2nd power is 4. What is 2 to the 1st power? 2. Okay. Now, look at the pattern that you see there. Okay? How do you get from 8 to 4? You can subtract 4, but subtracting 4 won't get you to 2 right here. What else could you do? Divide by 2. And 4 divided by 2 is 2. Well, if we divide by 2 again, 2 divided by 2, what is it? It's 1. So 2 to the 0 power would have to be 1. Okay? That's the truth even if you use a different number. If I did 5 to the 3rd power, it would be 125. If I did 5 to the 2nd, no, it would not be 125. No, it would. It would. Sorry. Lose my mind. 5 to the 3rd power, 125. 5 to the 2nd power is 25. 5 to the 1st power is 5. 5 to the 0 power, 1. Because each time you are dividing by 5 and dividing by 5. So when you get right here, 5 divided by 5 is 1. Right? Even if you had x to the 3rd power, that's x times x times x, right? X squared is x times x. X to the 1st is x, right? So if you think about it, what you're doing each time here is you're dividing by x, which cancels one of those x's out. And here you divide by x, which cancels one of those x's out. And here you would divide by x, and what is anything divided by itself? X divided by x is 1. So x of 0 would be 1 for that. The only time it doesn't work is 0. What's 0 to the 3rd power? 0. 0 squared is 0. 0 to the 1st is 0. And 0 to the 0, indeterminate. Because each time, you're not really, like you can't divide by 0, right? So this 0 does not follow that same pattern that we see with the other numbers. So any other number, any other variable is going to be 1, but 0 to 0 is indeterminate. Okay, so anything to the 0 power is 1. Make sure you remember that. That'll be important for you. Okay, negative exponents. Miss Hendrick, I believe, went into negative exponents some, didn't she? She did some of these. Yeah, negative exponents. I think she did them a little. I think she didn't do them at first and had to back up and do them because they were on the IXL, maybe. So, I don't know what she says when dealing with negative exponents, but I have something that helps me remember how to deal with negative exponents. Okay, I like little things that help me remember things like, for example, whenever you guys ask me how to divide fractions, I tell you it's easy as pie, split the second and multiply. This one's not quite as nice, but right now, this x to negative n, it's in the numerator of a fraction, right? We don't really see the fraction there, but we could put it over 1 if we wanted to, right? So, negative exponents are like bad children. And what should you do with children who are bad? You should lock them in the basement. Okay? So you take the bad children and you lock them in the basement. Okay? I like dungeon too, because we're not talking finished basement with a home theater in it here. That would do no good. The dungeon. We're going to lock them in the dungeon. And so, when you lock these children in the dungeon, because they're bad, it makes them good again, because the punishment, they learn from it, and now they are going to act like they are supposed to. So, you're going to send it to the dungeon, but when you do, it makes them good, so it makes their exponent positive. Okay? Right here. This is x to the negative n. Over here. X to the n. Okay? Alright, so when you move it to the bottom of the fraction, it makes the exponent positive. You have to have something in the numerator of a fraction all the time, so if there's nothing there, put a 1. Okay? If I wanted, I could keep that 1 right there, but 1 times x to the n is just x to the n. Okay? So, sometimes you have a problem and your castle does not have a dungeon. So you have like a cheap castle that didn't come with a dungeon. So if that happens and you have negative exponents that are in the bottom, so you're on the bottom floor, like your main floor is your bottom floor. Sometimes you have to improvise if you don't have a dungeon. If you don't have a dungeon, or the children are already in the dungeon and it's not doing them any good, you have to take them and you have to lock them in the attic. Okay? So when you lock them in the attic, it fixes them. They are now good, so their exponent is positive. It helps me remember. This is also my personal discipline policy. Before you report me, I do not lock my children in the basement. Okay. Alright, so you'll move this to the top. Now, do you have to have something in the bottom of a fraction? I could put this as x over 1 if I wanted, but I don't have to, so I could just write this as x to the n power. So if you have something in the bottom and there's nothing in the top, you have to put a 1 there. But if you move it to the top and there's nothing left in the bottom, you can just leave it x to the n. Okay? Alright, now, this is really important, this line right after those two boxes. Remember, negative exponents do not mean negative numbers. It can be either, but the negative exponent has nothing to do with whether it's positive or negative. It has to do with the actual number itself.
So
If
if the actual number is positive,
the actual number is positive, then it's going to be positive, correct. Now, if I had, so for example, on number 1 here, if I had negative 5 to the negative third, then it would end up being negative. But in this case, it's not. There are a lot of things in math that this is used for. Now, it is this is sort of one of those building blocks that you need to be able to do some upper level math. I doubt that your parents use it to balance their checkbook, but it is something that you need to be successful in upper level maths. So if we look at number 1, okay, we've got 5 to the negative 3. So we've got a negative exponent right now. That's in the top of the fraction. It is a bad child. We're going to throw it to the basement. And when we do that, it makes it better. It makes its exponent positive. No. It's damp and moldy down there. Okay. All right, now, there's nothing in the top, so we've got to have something in the top. So we put a 1 there. And what is 5 to the third power? 125. So our answer would be 1 over 125.
Well, see, I didn't know.
Okay. Thank you. I believe you have your worksheet on your desk. You have a question, Hayden? Or you have a question? Are you finished? Okay, good. Okay. Your notes should be on your desk. Okay. All right. Did you make a 92? I'm gonna check his log, make sure he's not clicking over. Check him. He's pretty smart. He might have got it. All right. Okay. All right. All right. X to the negative 4. Okay. That would be. It's in the top right now. We're going to move it to the bottom. We got to make it positive. Nothing's in the top, so we're going to put a 1. And we really already did this. X to the negative n. Negative exponent. Move it to the bottom. It makes it positive. Put a 1 on top. Okay. Now, the 0 exponent should be your easiest one. What is 5 to the 0? What is that? Y to the 0? What is x to the 0? 1. As long as it doesn't say 0 to the 0, it's just 1. It would be indeterminate. Yeah. So you would write out that word, but you're probably not going to see that. Okay? All right, questions? Yes, until we get to ones like number 10 right here, where we've already got some other stuff there, so we'll see those in a second. Okay, so, okay. All right, 7. Okay, negative exponent. Right now it's in the top. We got to move it to the bottom. Okay, nothing's left in the top, so we got to put a 1 there. Can't leave the 1 unoccupied. Okay. All right. So, 2 to the third. What is it? 8. Okay. This one, 8 is a little bit different. The negative exponent's in the bottom. So what do we got to do to it? Take it to the top. So in the top, there's already 1 there. So it could be 1 times 3 to the 5th. Do I have to put anything in the bottom? No, I could put a 1 there if I want, but I don't have to. And then 1 times 3 to the 5th is just 3 to the 5th. What is, that's 3 times 3 times 3 times 3 times 3, because we're not using our calculator here. So that would be, no, Adam, put it down. Back away. So that's 81 times 3, which is, let's see, 8 times 3 is 3. 8 times 243. That one. Good job. Without the calculator? You can do it without the calculator. I believe it. Okay. Mental exercise. Build up those muscles in your brain. Yep, 243. Knowing when to use the calculator and when not to use the calculator is very important. The stronger your brain gets, the less you have to. I don't.
I'm like max continuous. Unless you're taking steroids.
I don't know if steroids actually help you. Might help your muscles, but what you're saying might be somewhat true to an extent, but I don't think anybody here is maxed out yet. Anywhere close to maxing out. I mean, it might be true to some extent, but I don't think anybody here is maxed out. No, I don't think so. I think Dylan's moved around to a lot of schools and not had continuous math instruction. Yeah. I hope that he'll get to stay here for the rest of his. He should hopefully get to stay here for the rest of his career and improve. Yeah, mathematical career. All right. All right, quiet please. Okay. All right, now 9 is one a lot of people will do wrong. It's really easy, but a lot of people will do it wrong. This -2 right here only goes with the x. It does not go with the 2. Okay? So unless there's parentheses around it, the -2 only goes with the variable right in front of it. So the only thing that has a negative exponent is the x. So you're going to throw it to the basement. The 2 stays in the top. The y, you're moving the x with it because that's the base that goes with it. Let me erase it so we can see that a little bit better. Fix it. So that x with the exponent goes to the bottom. I just like to put the x first. I'm going to put x squared. And the y to the 4th, it doesn't move because its exponent's positive, so it stays right where it's at. If you want, you can put the y first. Typically, most books put them in alphabetical order. Put your variables in alphabetical order. It is correct to say y to the 4th times x squared. That's correct. It's just usually not what your answer choices are going to look like if it's multiple choice. And most of the time you'll see, if these are given, like on a quiz on Canvas or on, if it's not like just writing out the answers, you'll usually see them multiple choice because they're hard to type in. Okay. Yeah, we'll have a quiz on this probably early next week. Final exam, you'll have a state exam for this. This is an EOC. Okay? All right. So, Adam, number 10. All right, tell me what the answer is.
You want to give me a second?
Yep.
Do I move the A, down? Am I moving B to the negative second?
Yes.
To the top.
Yes.
Okay.
So what will that give you?
Hold on. It'd be A to the 3rd, and then B to the negative second up top.
Oh, whenever we throw him in, when we lock him in the attic, that corrects him. So it turns into a positive. It's an effective discipline strategy for negative exponents. It works every time. For negative exponents. Actually, my kids love the basement, so I mean we don't have a finished basement, but their bicycles are down there and they like to ride their bikes around, so it's not a good punishment. So it's not a good punishment for them. My kids find something to play with everywhere. There's no good punishment for them. Okay. Oh, there we go. Okay, questions? Yep, that's the answer. Because they're A and B, you can't put together. You can't divide it by 4. There's nothing else you can do to that.
Hey, I did number 11.
Okay. All right. Now, this one you got a couple options. You could deal with the negative exponent first, or you could deal with the square on the outside first. It really doesn't matter which one you do first. Let's do the square on the outside. That's the one I'm going to pick. So if you do the square, this is a power to a power. When you do this, you've got to raise the 3 to the second power and the x to the -2 to the second power. So you're doing, because this 3 right here, it has a little invisible 1 right there. So you're doing 3 to the second power, and then x to the -2 to the second power, which is going to be x to the -4. And what is 3 to the second power? Is 9. And you could have done that part in your head if you wanted to. That'd be fine. So we've got to deal with that negative exponent. So, Madison, what are we going to do with that negative exponent? Go to the bottom. So what will that give us for our answer? Okay. Does the 9 go? It does not. So 9 is going to stay on top. And on the bottom, what will we have? X to the positive 4. Okay. Make sure, the biggest mistake I see is students moving that 9 with it because it looks like it all goes together. But you don't move the coefficient unless you have a problem like number 12. And then we're going to see why did the 9 not go?
No, I just did 9x and then -4.
Even if the 9 is negative, it would still stay. The only time that it's going to move is if its exponent is negative. Okay? So, like, if I had, so, for example, if that had been a negative 9 right there, it would still stay on the top and just be a negative 9. It's only when the exponent is negative that you send it to the bottom. So that's a good question. Because a lot of students get that part wrong. 9 does not have an exponent. So the -4 only goes with what's right in front of it unless you have parentheses. And we don't have parentheses saying that it goes with both the 9 and the x. Okay? But if you look at number 12, this time both of these go to the -3, right? So we can do this like we did the last problem, or we could move it first. It's up to you. I think I'll do it like we did the last problem just for consistency. So if I raise both of these to the -3, okay, this is 5 to the -3. It is not -125. Okay, 5 to the -3. And then x to the -6. Now, this time, that 5 did end up with a negative exponent, right? So this time, both of these have to go to the bottom. So I'm going to move the 5 to the bottom, and it'll be 5 to the +3rd. I'm going to move the x to the bottom, and it'll be x to the +6. We have nothing left on top, so we've got to put a 1 there. And Ian, what is 5 to the 3rd? 125. So we got 1 over 125 x to the 6. This one, see how up here we had a positive exponent we were raising this to? So when we did this, we had 3 squared and then x to the -4. So that 3 had a positive exponent, so it didn't go to the bottom. But this time, we're raising both of these to negative exponents. So we've got 5 to the -3 and x to the -6. They both have negative exponents, so they both have to go. Okay, questions? All right, let's look at 13. 13, there's several different ways you can do 13. Okay, is this a power to a power? It is not. We do not have parentheses with a power. This is same base multiplied together. What do we do when we have the same base multiplied together? We add the exponents. What is -5 plus 7? It is +2. There's your answer. So the negative exponent took care of itself this time. That is not the only way you could do this. You could have sent that to the bottom. You would have had a to the 7th over a to the 5th if you sent that negative exponent to the bottom. But then, what do we do when we divide exponents? Subtract. So 7 minus 5 would be a squared. It'd give us the same answer if we did it that way. All right. So pretty much with exponent rules, there are a few times you have to do one thing before the other. Like on 19, you've got to do that exponent before you. No, not really. Actually, you can do it. You can do one thing before the other. But if you follow the rules each time, then you eventually will get to the right answer, even though what you do may look different than somebody else. Okay. 14. Let's see. 14. What do you think? Okay, we're going to multiply first, right? So let's do these exponents. Make sure you do the 2 and the a. So you're going to have 2 to the negative 2 and a to the positive 2 times 2 to the 4th and a to the negative 4th. And then a few different ways you could do this as well. What I would do, you got 2's right here. That's the same base, right? What can we do with their exponents? We can add them. Okay, even though it's a number instead of a letter, we can still add their exponents. So that would give me 2 to the negative 2 plus 4. What's negative 2 plus 4? Is 2. And then I could do the same thing with the a's. A to the 2 plus negative 4. What is 2 plus negative 4? Negative 2. Okay? And so we're not quite done because we got those negative exponents in general. I don't ever want you to leave a negative exponent in your answer. So, Cole, what are we going to get when we finish this one up? Can I put 2 and a together? Are they the same base? No. To put them together, you got to have the exact same base. You'd have to have an A and an A or a 2 and a 2. I could put this. So what I did just on the last step is I took this 2 and put it with this 2. So I added their exponents. Negative 2 plus 4 gave me 2. And I took this A and put it with this A. So I added their exponents. 2 plus negative 4 gave me negative 2. But I can't put the 2 and the a together because the bases are different. So I've just got to keep them separate. What is 2 to the second power, Cole? It's 4. And this a has negative exponents. So right now it's in the top of the fraction. What do I need to do to it? I'm going to move it to the bottom. And when I do that, it'll make it exponent positive. So you get 4 over a squared. I'm explaining these probably more than they need. Well, I mean, the more you do of these, the quicker you should be. I'm explaining them slowly, hoping that you guys follow well. I can do these really fast. Really fast. Yeah, you're right. I should be able to. Yeah. Can. 1 over x to the 6th. Okay, look at that. Look at 20. All right. Y to the 4th. What is y squared squared? Because Adam challenged me to do that one in under 5 seconds, and I could not resist the challenge. Okay. So what is y squared squared? It is y to the 4th. You multiply your exponents, power to a power, right there. So what happens with y to the 4th and y to the 4th? Those cancel. Okay? What do I do with this x to the negative 3? It's got to go to the bottom. So that means I'd have an x to the 3rd and an x to the 3rd in the bottom. And that is x to the 6th. There's nothing left in the top because I canceled this out, so I got to put a 1. Okay.
Why don't you try on 16 through 24?
23 and 24.
23 and 24. Oh, 23 is so easy. It's x to the 14th. Why is that one so easy? Everything on the bottom is just 1 because it's to 0 power. So there's no work to be done there. So it's just x to the 14th. Okay? 24 will take me just a little bit longer. I might have to write things down a little bit on that. but I can do it. Maybe not. I might not be able to do this one in 5 seconds.
10 seconds.
I could take your 10 seconds.
Alright, start again in 3.
Okay, I can do it. I'm going to do it.
She already has half of it worked out.
All right. That's it. Fast. This. You guys can be this fast one day too. That did not take me 31 seconds.
I said we're starting the 30-minute part. Yeah, look at the little counter thing on the bottom left of the.
What are you even? Oh, over here? Okay. On 30 seconds? It wasn't right at 30. I did that faster than 31 seconds. I did it faster. Alright. But let's go over a few more. As much as I love impressing you guys with my skill of fast math that I have worked on for the last 12 years straight, I want you guys to understand how to do this. Let's look at 17. 17 throws kids off every time. Okay? 17 throws kids off every time. Okay? For 17, you've got negative 48 over 32. Do you move 48? You do not. Does it have a negative exponent? No, it does not. So this one does not move. Negative coefficients do not move. Okay? It's only when their exponents are negative. So what you've got to do here is you are just going to reduce 48 over 32 if it will reduce. Is there anything I could divide both of those by? 2 will work. Is there something bigger? 8 will be your best bet. So if you divide this by 8, 48 divided by 8 is 6. And then 32 divided by, actually no, there's something better.
16.
16 is going to go into both of them. Okay? If you divide this by 16, you'll get negative 3. And if you divide this by 16, you'll get 2. So you're just going to reduce those coefficients. And sometimes you might have to, like, if you didn't see 16, divide it by 2. And if you still got even numbers, divide it by 2 again, and then 2 again, so you get, yeah, it does take too long. If you use 16, it goes into both of those evenly. If you don't see it, you can always do, you got 48 over 32. You might see, 4 goes into both of those. So if you divide them both by 4, you would get negative 12 over 8. And then if you divide both of those, you can divide by 2, so you get negative 6 over 4. And then that still reduces to negative 3 over 2. So if you don't see it right away, you can just, take steps to reduce it. All right, now, if I wrote this out the long way, some kids just need to write it out the long way. It confuses you too much if you write it the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would rather you be slow. I would rather you be slow than wrong.
That's like me and the math test multiplying everything.
Okay. All right, so long way. If I got an A on top and an A on bottom, it cancels. If I have a B on top and a B on bottom, it cancels. Okay? So you can do it that way, but there's a quicker way. Yes. Did I? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's only supposed to be 3. Sorry. Let's fix that. That one should not be there, which means this one should not be marked out. Thank you. Now, thank you for your. One time when Miss Hendrick was subbing for me, she had just subbed like that morning, and I had a dentist appointment or something. I came in at the end of class, and she was trying to help a kid, and bless his heart, he couldn't do anything. And she was getting a little frustrated with him. No, this was a long time ago. I can't remember what his name was. And actually I do remember who it was, but it's been a long time. You wouldn't know him. And he was doing it wrong, and she was trying to get him to fix his mistake. And she was saying, okay, no, that's not right. You got to fix it. And he just kind of sat there. He didn't even know what she was talking about. And she said, okay, you got to change that to a 6 or whatever she's trying to do. And he was still not doing anything. She said, okay, take your pencil, turn it over. And she turned his pencil over home. Erase that. So she was really giving step by step, and I thought it was hilarious. She was really. So that's kind of what you just did to me whenever I had my eraser there. All right, so that's not important. So if you look at this, how many you got a 3? How many B's do you have on top? 1, 2, 3, 4, 5, 6, 7. And how many A's do you have on bottom? 3. Okay. Now, let me show you how to do that so you don't have to write all of that out. Because that takes a while, and you might do something stupid like I did and write too many A's, and then you'll miss it. Oh, yeah, sorry. I lost my 2. Yes, thank you. And it's negative. Thank you. I'm losing all kinds of things. I was showing off too much earlier, and now I'm embarrassing myself. Okay. All right. It does. You're right. I'm getting taken down a notch. So if we look at this, let me show you a different way you could have done this. Whenever we're dividing, what could we do with our exponents? When we're dividing, what do? We subtract our exponents, right? So I could have done this. 4 minus 1 gives me 3, but the 4 is on the bottom. The bigger number is on the bottom. So when I get 3, it's going to go on the bottom. So there's my a to the 3rd, right? And 10 minus 3 gives me 7. The bigger number is on top, so the b to the 7th goes on the top. Okay, so that makes it a little bit quicker to do.
Where'd you even write it?
I didn't. So 4 minus 1 would give you 3, right? And there's more A's on the bottom than the top, so that a to the 3 goes on the bottom. And then b to 10 minus 3, so you do 10 minus 3 will give you 7. The most b's are on top, so that b to the 7th goes on top. Same thing as doing it the other way, just quicker. Okay? All right. Let's go. Let's see. I want to get several. Let's go back to 16. All right. 16. What is 6 squared? 36. All right. All right. Shh. Guys, we just have a few more minutes. Pay attention. Okay. All right. A to the negative 2. What can I do with it? Send it to the basement. All right. So, b to the 3rd. So I've got 3ab to the 4th. And then I've got that a squared I sent to the basement. All right. Now, what could I do with these 2 a's that I've got right here? Put them together. So that gives me 36b to the 3rd over 3a to the 3rd b to the 4th.
Is that a 6 and a b?
Yeah. Yeah, this is a 6 right here. 36b to the 3rd. All right, 36 and 3. Can I reduce those? I could divide them both by 3. I'd get 12, and on the bottom I'd just get a 1. Right? So I would have, I could reduce those. What about the b's? I would subtract. It'd be b to the 1st. Would I put it in the top or the bottom? The bottom, because there's more b's on the bottom, right? So that means if I subtract them, this would be gone. This would just be 1. And so I would get 12 over a to the 3rd b. Okay? Aiden, I want you to help me with 21. So, what do you want to do first?
Are those b's?
They're z's, yes. They do, kind of. It's on your paper, though. They're Z's. These are Z's. They're not equals. 21. All right, Aiden. What do you think you can do? All right, 28 divided by 4. 4 will go into 28, right? What do we get? 7. So on top here, we'll have a 7. The 4, that'll just be a 1. All right, we'll divide both of those by 4. That's good. What is x to the 0, Aiden? It is just 1. So essentially that's going to cancel out. And all those negative exponents, I just really don't like them. So what can we do with those negative exponents? Okay, if they're upstairs, we're going to throw them in the basement. If they're already downstairs, we send them to the attic, right? So I've got 7. I've got y to the 15th. Z has a negative exponent, so it's got to go to the bottom. Z to the 4th. I'm just kind of going through each one. 7 times 1 is just 7. Y to the 15th just stays on top. Z to the negative 4, it's got to go to the bottom. Now I'm going to go to the bottom. I've got x to the negative 1. Since it's got a negative exponent, it's got to go to the top. So that's x to the 1st. Y to the 6th, it just stays on the bottom where it's at. Z stays on the bottom where it's at. If you've got more than one of a letter, you need to put that together. So I've got 2 y's here, and I've also got 2 z's, so I need to combine those. So if I combine my y's, what do I have to do when I have division there, Aiden? Subtract, and when I subtract 15 minus 6, I get 9. And so, does that go on the top or the bottom? Top or bottom? Top, because this 15 is bigger, right? So y to the 9th. I'm going to leave that x right there. So that gets rid of we got rid of that. The x stays where it's at. The z to the 4th and z to the 1st, I can put those together. What will I get? Z to the 5th. Now, answer choices are probably going to have this as 7y to the 9th. I'm sorry. I'm not fixing it. Why is it not working? Come on. Oh. Giving up on me. Okay. It's probably going to be 7xy to the 9th over z to the 5th. Guys, quiet. Okay. Probably, they usually put them in alphabetical order. It's correct either way. I'm not going to count off for this, but if it's multiple choice, it'll look like that second one. Okay? All right, your assignment tonight is to do through number 30. Okay? So, tonight, you're going to finish through number 30. So do all the ones we haven't done up to 30. Jesus, what's homework? Oh, you were talking. Gabe, tell him what homework is. 1 through 30. Okay, you should have most of those already done. Ian, what's homework? 1 through 30. Good. All right. Monica, what's homework? 1 through 30. Aiden, where you at? What's homework? Good. Okay. Good time, man.